look for you.
So you are looking for something that's like the same.
The same amount instead of like a doubling or cutting in half.
Okay.
Mhm. Okay, so that kind of took care of it. 13. We feel okay with that. Mechanisms. You guys want me to find you a different problem. If I just make up a mechanism, I don't know how great it'll be. Is that okay?
Mhm.
All right. So if we have like a reverse mechanism. Okay, obviously this is like crazy. Okay. Let's see how it works out. Okay. We'll do 2C here. Okay, so then in this would have to be your fast reversible, and this would be your slow one. So far, so good? Yes.
How do you know it's slow down?
You would be told.
Oh, okay.
You have to just be told that information. So this would be like I gave you a reaction mechanism, and then you had to figure out, is it the right reaction mechanism, or what is the rate law, or something like that to determine it. And so if we were to look at what an overall reaction might be for this particular one, what would be in my overall reaction? What would not be in my overall reaction?
2C.
My 2C's, okay? Because those 2C's are my intermediates, right? Okay, so then what else can I get rid of? B, and what, oh, I have nothing made. This is a pointless reaction. Okay, so like I said, this is what happens, we just make stuff up. But anyway, so B then would be what? A catalyst, because it started and it ended your reaction. Okay, so then it looks like we canceled everything we could, so my overall reaction would look like this. Are we okay with my made up equation?
Can you explain like I kind of know, but can you explain the difference between like a catalyst and intermediate?
Sure. So the intermediate is going to be something that's made throughout the reaction mechanism and then used up within the reaction mechanism. So it has to start as a product somewhere and then end as a reactant somewhere. That would be your intermediate. Whereas your catalyst would then be the opposite. It starts as a reactant somewhere and ends as a product somewhere. So your intermediate would always be something that's made and then ignored. And that's important because we know our intermediates can't be in our overall rate law. So if we were to go and see this setup right here, my slow step is the one that determines my rate law, right? So for my rate law, I would be putting together the information from my slow step. We only put reactants in our rate laws. And since it's an elementary step, I'll actually be able to use the coefficients that are there in the equation. So all rate laws always start rate equals K times stuff. So I'm going to put my two reactants, C and D. And since I have two C's in my equation, I'm going to use my coefficient from my equation as my sorry, I realized I have a mistake here, but anyway, so I have two C's because my coefficient is right there.
So why is that still in the equation?
Because I'm not done yet. Because I'm not done yet. So you guys have exactly a good point. I have to get rid of that C, right? It's an intermediate. I have to get rid of it. So I need to replace it with something else. So when I go to replace it with something else, I need to look at my reversible step. My 2C is the same here as A plus B, right? Mm-hmm. So here's where we're going to run into a little trouble because I just sort of made this reaction up, right? So it's not working out the way that I want it to. I'm going to take a step back and get rid of B here bit, just because otherwise this doesn't work the way it's supposed to. But that's just because I need something up. Okay, fair enough. Everybody's okay. It's a catalyst. We don't need it in our reaction anyway, so we're just get rid of it. All right, so that being said, you guys made a good point. I can't put C in here because it's an intermediate. I had to get rid of it. So I'm going to replace it with something that's the same as C. So in my reversible reaction, I'm told right here, because this goes back and forth, that my two C's are coming from A here. So I can replace C with what's happening with A. And so then when I bring that down here, I'm just going to replace those out. And now I've created a new rate law that doesn't have intermediates in it, but still includes my reactants that are the reactants in my balanced overall equation. Once again, coincidentally, it happens that the coefficients here match the coefficients here, but that won't always be the case. Sorry, something is happening weird with my video. Yes, we can see.
I think we had like a practice problem where it had two reactants on the fast one. Would you just include both of those or do it?
Right. And so because B ended up being removed from my overall equation, it wasn't in my overall, so that's why I had to pull it out. But yeah, if there were two, you would have just replaced them both in there.
There was a problem that asked what the full order of a reaction was, and I misread.
Okay, but this overall order would be second order.
So, I mean, we don't get docked for not having that stuff where we took the catalyst into the equation, right?
Like in this example right here,
Yeah.
I had to, it's just because I was just making things up and my made up stuff wasn't matching what I wanted it to, so I had to fix it.
Okay, I see.
But you wouldn't do that in another situation where I had spent more than 10 seconds thinking about a problem. I probably would have been able to put a better problem out there for you. You can only use them within a reaction mechanism's elementary steps. It's the only time. Like this particular situation where you're trying to use your slow step to find your rate law, that's when you use your coefficients. All the rest of the time, you'll have to do all the rest of the stuff, graphing it or experimentally determining it. A and D being first order here. Yep, and here there's one, so it's first order. Right, so these are both elementary steps. So I can use the coefficients because they're elementary steps within a reaction mechanism.
Okay.
But I couldn't say, well, that's one,
Oh.
so this is one. I couldn't use this overall, but I could use these. Sorry, I must have been unclear.
Okay, that was my question too, but will your overall sometimes have like different
Yeah,
coefficients? Okay.
so it could have been, I mean, I was just making stuff up, so I could have said this is 2A, right? And then this would have been a 2 here, and that wouldn't match, but it'd still be right.
So like a question you could ask on the test, like I think one of them was on the AFL or like on a different worksheet, and it was like, does the overall rate law match like the, I don't know, and it was like, yeah, I don't know how to ask it, because it was like, there was a question and it was asking like if the overall rate law matched like basically the addition or like the rate law of the elementary steps together.
I remember that question. But I don't remember.
Yeah, but I'm not helping explain it, so.
Okay.
I don't know.
Okay,
I remember.
I'm gonna get Mackenzie's question while you guys look for it, and then I have guesses on what it is, but I have several, so if she can't figure it out, I'll start going through things and we'll see.
Okay.
Okay, so what I was saying a second ago is I wasn't saying that your rate law doesn't match.
Right.
I was just talking about the coefficients, but
With the coefficient, like, just like theoretically, if you kept that 2 there, but it transferred out to the 2 on the overall reaction?
yeah,
Okay, I just wanted to make sure I wasn't like missing something
Yeah.
where
it would. Let's make an A over here. There you go. So now one of my A's would cancel, and so now there'd be one. making things up. I'm sorry. Sometimes that's confusing, but it demonstrates what I wanted to do. So reaction mechanisms, there's two things that make a reaction mechanism true. We've spent a ton of time talking about this catalyst thing because it's the hardest part of it, but don't lose sight of the other things you need to know. Like if this hadn't been reversible, this has just been a fast reaction versus a slow reaction, you would be able to just simply look at this and, well, the setup would have been slightly different. But kind of remember that the two things you're looking at is, do your overall reaction match? Does your overall reaction match? And then does your rate law match? And so like those are the big things with reaction mechanism to be concerned about. The catalyst thing is just a thing to make sure you know how to do.
Does your overall reaction match what?
Do the two steps, does the sum of the two
Cancel
steps
out.
cancel out to meet your overall reaction? And then does your rate law for your slow step match your rate law for your overall equation that had to have been determined experimentally? So those are the two things that you would check for if you were to ask, like, is a reaction mechanism correct or not? Those are the two ways you would prove it. Sorry.
So if it was just fast, would that like specific, like would those specific elementary sets like come out to have that?
No.
If it was reversible, like how would that look?
Okay, so I kind of would do a setup like this, right? I think I have to make sure this matches. So then when I go to do the sum, now the C didn't cancel out. And my two A's did. And so now when I look at this, I would have a different rate law. It would now be, this would now be my rate law. But it's okay because neither of those are intermediates. And so they both are in my overall equation. So kind of the difference. And then I need to include, that was it, just.
Okay, what's the point of, like, the purpose of writing the rate law with the C to the second when you could just know your product or your reactants on the final reaction or B and B? Like, why can't you just originally put them in as B and B? Like, you know how you like crossed out the C to the second?
So now, like in this particular reaction, like the way I've changed it here, that wouldn't have happened.
You're like, why'd you put?
Why did I do it originally?
Why'd you put the C to the second there instead of just putting the A there originally?
Because I was making a point. I was just showing you that that came from the C from the equation here. But then we recognized we had to get rid of it because it was an intermediate. And so then I replaced it with what the intermediate part were. I was kind of showing you the train of thought. But yeah, if this were a test, you would have just said, oh, look, that's an intermediate. I'm going to replace it with this and write a rate law. So far, so good? Okay, questions for me? Okay. Yes, sir.
Do you have to point out like which ones are intermediate and stuff in our?
Not unless you were asked. It would be like an explicit question. But we've talked about it a bunch, so I wouldn't be surprised if you have a question that asks that somewhere along the game. So far, so good. Okay, I'm going to start answering questions on the kinetics practice. 1, we'll do 2, 4, 6, and 13. Okay, so number 2 is simply the idea that you can use the coefficients from the equation as your mole ratio to help you determine your rate reaction. And so the general idea of what you do when you're trying to find the rate of a reaction. And I think this is a good thing to talk about because I've gotten this question from a few people. Let's just assume it's in seconds. Okay, so these things are all interchangeable, and we've talked about them. We haven't talked about this as much because we don't do this very often because you're usually just given the rate. But the rate of a reaction is going to be based on how much of your concentration is changing over time. That's why your rate your rate unit is molarity per amount of time, so like molarity per second. So when you're looking at it, a very fast reaction is going to quickly get rid of your molarities. So you'll have a large number of molarity per second. A slow reaction is going to get rid of your molarity slowly, so it'll be a little bit per time. So that's why when your reaction goes faster, your rate actually goes up, because it's how much molarity is changing per second. That kind of makes sense. Okay, and so given an equation, your mole ratio, if we're just looking at how the rate is changing over time, it will change based on what's happening stoichiometrically in your equation. Every time 2 of these react, 3 of those are going to react, and 4 of those are going to be made. So proportionally, your rate's going to be affected the same way. And so if this is basically your idea of how your rate is changing, concentration per time, we can look to see how those will be affected just by putting in the mole ratios. So this is always your general equation to solve for rate. So if you wanted to show it proportionally, I would just plug in my mole ratio values. So the coefficient is a 2. So it's going to be the same change that I would see for 3 moles of O2 changing per time. And then 4 moles of NO2, molarity. And then because these 2 are both reactants, we know over time their amounts will be decreasing. Their molarity is going to go down because they're being used up. So that's why I made these 2 negative. And this is a product, so I made it, well, I didn't make it positive, but it is positive. So proportionally, their rates will always change the same way. So where you would use that would be in 3. And so you didn't ask me about 3, so I won't go through it, but basically 2 and 3 are really similar. 3 is doing the math of what this is showing. That makes sense? Questions for me? Okay. Then we're going to talk about 4. So on number 4, it's the going backwards of the idea of you've given the rate constant and you have to figure out what its molarity would have to be, or its order has to be based on its units. So there's a handful of ways you could do this. So if this is liters times moles to the -1 and seconds to the -1, it's going to be the same thing as liters over moles, which is the same thing as molarity to the -1. All of those are the same. So since this is the number that we're looking at, to help me identify what our order is going to be, and we know your order always has to be 1 more than that. So if those are both -1, then my order has to be a 2. Mathematically, we kind of work backwards if you guys want to, because in a rate equation, you can figure out what that would have to have been. So if this is molarity per second equals right? And so we would just need to kind of work backwards to figure out what it is. And when you do that, you end up having the only way to make that work. Just making sure I wrote that in there. This would have to be molarity squared. So you have 2 molarity, so when you cancel that out, it still matches the other side. Can't tell if you guys followed me or not. No?
I did.
Basically, like,
My Google Hangouts is being an insane person. Hi. Welcome.
Thank you.